topic correlation and regression. So we have discussed the part already. So let me continue with this. Correlation. Correlation analysis is a method of statistical evaluation used to study the strength and relationship between two components. Here, two components means we have taken as a pair xi, yi. One may be dependent, the other may be independent. So, as per the definition we have discussed, coefficient of correlation, this equation A represents the Carl Pearson coefficient, which is given by covariance of xy by root of variance x variance y. That is the second line. Third line, we are defining how to find the covariance. That is in third line, the covariance of xy is nothing but 1 by n sigma xi minus x bar yi minus y bar. What is x bar is nothing but mean. If you are able to find the mean, you can use the first one. If not, you can direct formula to find the covariance. That is 1 by n sigma xi yi minus sigma xi by n into sigma yi by n. And one more we have required to find the formula, that is variance of x and variance of y. The same formula again, 1 by n sigma xi minus x bar. If you know x bar, you can use the first one. If not, you can calculate the formula from the data provided, that is xi and yi. Okay. The next one is the Carl Pearson, that is the last but second line. That is Carl Pearson, that is the direct formula. Instead of A, you can use the direct formula without finding this covariance and the variance. Without finding that, you can use the formula, the last one, that is the Carl Pearson formula. The other one is Spearman, that is we have discussed earlier. Correlation coefficient and the Spearman rank correlation coefficient. So let me have an introduction that what you have discussed, recall what you have studied, that is regression x1. So the regression provides the relationship between the dependent variable and one independent variable. Okay, so correlation means the association. Is there any association between two variables? That is what? Is there any association between two variables, x and y? And before going to the part, we have this basic concept, that is this Carl Pearson I have done that Rxy equal to this Rxy is independent. That is the correlation coefficient is independent of change of origin. That is R of xy is nothing but R of uv. What is u and v? It is our choice to diminish the variable xy in order to make the calculation simplified. That is R of xy equal to R of uv. So that means uv becomes the same formula, that is Carl n into sigma uv minus sigma. So don't forget this basic concept. This correlation coefficient is independent of change of origin. Next one, regression. Regression, just before I told, we used to find the relationship between x and y. So there were linear regression lines, two regression lines. One is y on x, other one is x on y. In the last class, we have discussed how to calculate this formula, what you have provided here. C and D are the regression lines to find y on x and x on y. Here I have written here the second line of this regression equation y on x, vyx, that is called regression coefficient, n into sigma xi yi. That is in case of discrete data. We have discussed this problem already in case of discrete. Okay. So that means for this part, the continuous case, that will be the summation will be replaced by the integration. So once again, we recall the fact, regression line y on x, that is I am talking about the equation C. Y on x means y of x. X is independent variable, y is dependent variable. The same way for the equation x on y means x of y. That is y is independent variable, x is dependent variable. Okay, so x minus x bar equal to byx into y minus y. Okay, so look at this equation D and C. Byx is nothing but Rxy into sigma y by sigma x. Sigma y means standard deviation of y. Sigma x means standard deviation of x. Okay. So if you are able to find this value, correlation and standard deviation as given, we can use the formula. Even otherwise, we will use the direct formula. Okay. Now let me see what will be the how to find this regression line in case of this bivariate data. Okay. So here we are going to find the basic things, how to find the marginal density function and the conditional density function for this joint distribution is given for the random variable x and y. F of xy, that is the first one, f of xy equal to 2 by 3 x plus y. The limit of x is from 0 to. The limit of y is from 0 to. That is the second line. Otherwise, this distribution is 0. Elsewhere, outside the region, we say that is f of xy is 0. The marginal density function of x is defined as f1 of x equal to integral minus infinity infinity fxy dy. Marginal density function of x means it is the region we integrate with respect to y. That is the third line of the equation f of xy equal to dy. What is the limit of y? Y is from 0 less than y less than 1. So the limit of y is from 0 to 1. So here written the limit y equal to 0 to 1. 2 by 3 x plus 2 by. When we are integrating this with respect to y, we are getting this 2 by 3 x plus 2. So I have written the marginal density function f1 of x equal to 2 by 3 x plus 1 in the limit 0 to 1. X is continuous variable. Okay. So same way we are going to find the marginal density function of y. How we find that is f2 of x equal to fx of y dx. So that is what the next part we are finding that marginal density function of y is f2 of y in the place of here marginal density function of y means the limit is from x limit. Here x limit is also from 0 less than x less than. So the same here there is no change in the limit, but we are integrating with respect to x. Okay, what we are getting is 1 by 3, 1 plus 4y. So the marginal density function of y is given by f2 of x. Next one, conditional density by definition. It is nothing but a joint density by marginal density. That is fxy by f1x. So fxy in the previous slide we are having this first one given fxy equal to 2 by 3 x plus 2y, and we have find out f1 of x 2 by 3 x plus 1. Just take the fraction of it. So what you are getting is x by 3 f of xy, it is x plus 2y by x plus 1. So the regression curve y on x is given by y equal to the conditional density, that is the expected value of y given x equal to. It is nothing but according to the formula integral minus infinity, that is the limit of x y into the conditional distribution f2 of y. When you are integrating the value, we have already calculated f2 of y by x, that is the conditional density. When you are substituting this, we are getting this y equal to 0 to 1, y into x plus y. The last, but the next time, y equal to 3x. Same way, we can find the conditional density function of x given y. That is the fraction of the joint distribution by the marginal density function of y. So taking the ratio, we are getting the least square term. So it is given by this equation. Okay. You see one more problem of this type for the joint distribution. So here we are asked to find the regression line y on x and x on y. They are given the joint density function f of xy equal to 2 by 3 x plus 2y. Almost the same problem what we have discussed earlier. So the same marginal density functions because the first line fxy dxy, we have explained here how we have integrated 2 by 3 x plus 2y with respect to y. So 2 by 3 is constant, you can take it outside. Integration of x with respect to y is xy. Integration of 2y with respect to y is 2y square by 2. That is the second line of this problem. So substitute the upper limit and lower limit. That is x plus y equal to 2 by 3 x into 1 minus 1. So that is nothing but 1 square minus 1. Upper limit is 1, so we are substituting 1 minus 0. Lower limit is 1 minus. For the next term, it is 1 square minus. By simplifying, we are getting that 2 by 3. That is, I am talking about second line, that is 2 by 3 x plus 1. So, what we are getting the marginal density function. The same way, the next one, how to find the expected value, that is the mean value. That is x bar, E of x equal to, by the formula or by the definition, it is integral minus infinity x into marginal of x. There is nothing but, you know, the limit of x, that is the last line. Limit of x is integral 0 to 1, 2 by 3 x into x plus 1 dx. Because that is when you are making the integration, what you are getting is x square plus x multiplying by x. Integration x square of x is x cube by 3 plus x cube by 3. The limit is 0 to 1. Apply the limit 1 cube minus 0 by 3. The other for the next term is 1 square, that is the last two lines. And simplifying, we are getting E of x equal to y by n. In the same way, we have to find the marginal density function of x. We are finding expected value. Expected value of the earlier part, we have find expected value of x. Now we are going to find the expected value of x square. Same definition. In the place of x, we have to replace by x square. Look at the second line, that is integral minus infinity x square f1x dx. That is integral 0 to 1, 2 by 3 x square plus x plus 1. That is x plus 1 is nothing but the marginal function. 2 by 3 is constant. X into x, it is x cube. When you are integrating, it is x square x power 4 by 4. The same way we can substitute the upper limit. Upper limit is 1. So 1 power 4 minus lower limit is 0. So 0, 1 minus 0. That is 1. That is for the next term. Upper limit same x cube. That is 1 cube minus 0 cube. That is nothing but 1. So simplifying, we are getting 7 by 8. That is in the first line. So that is nothing but E of x square equal to 7 by 8. In the third line, the variance of x. From this, we can find the variance of x. By the definition, variance of x equal to E of x square minus E of x whole square. Last but 1. So when we are substituting the value of the E of x square, the variance and the variance value can be found by substituting the value. That is 13 by 160. Okay. Similarly, we can calculate for y. The marginal density function of y, that is f2 of y in the first line, integral minus infinity fy dx, nothing but integral 0 to 1 x plus 2y, integrating with respect to x. Integral of x is x square by 2, first line, plus 2xy, that is limit is from 0 to 1, integral of x, then it is 2 by 3 into upper limit is 1, so 1 square minus 1 minus 2x square. We are substituting limit for x, so 2y is constant. So we are substituting limit for y, that is 1 minus 0 equal to 1 by 3, 1 plus 4y. f2 of x equal to 1 by 3, 1 plus 4y. So what we have calculated, I have written summarized. This one, the expected mean value of y is E of y equal to, in the place of x, by definition, integral minus infinity x into f2 of y dy. That is 1 by 3y, 1 plus 4y from the marginal distribution of y. Again, we are integrating with respect to y. Integral of y is y square by 2. The next time is 4y square. 4y square. If we integrate 4y square, we will get 4y cube by 3. You have to substitute the limit for y. Y limit 0 to 1. Substitute the limit for the first one, that is y square. We are substituting the limit. Upper limit is 1 square. Lower limit is 0. So 1 square minus 0 by 2. Second term 4 by 3. That is 1 square minus 0 by 3. On simplifying, we are getting 11 by 18. Next, we have to find the expected value of y square. That is the last third line. That is E of y square equal to integral minus infinity. By definition, E of y square means y square f2 of y. Integral 0 to 1 y square 1 by 3 1 plus 4y. 1 by 3 1 plus 4y is nothing but marginal density. Again integration 1 by 3 is constant, we can take it outside. That is this y square by 3 times comes for y square. Integral of y square is y square by 3. Then 4y square we have integral of 4y cube. 4y cube is 4y power 4 by 4. Yes, substitute the limits for y term. That is 1 by 3. Y cube means 1 cube. For y cube we are substituting the limit 1 cube minus 0. And we are substituting the limit for y 1 power 4 minus 0. Simplifying, we are getting 4 by 9. Either you can write in fraction or you can write in decimal. It is of your choice. The last but one line, variance of y. By definition, variance of y is e of y square minus e of x whole square. So what you are getting is this variance of y equal to, substitute the value e of y square minus e of x square. We are getting the value variance of y, the last line. Okay. So now we have calculated mean value and the variance of value. Next we have to calculate the covariance. So for that we have to find the expected value of xy. Expected value of xy, same way, e of xy equal to double integral y, because two variables, bivariate variable xy. So we are finding the limit integral minus infinity to infinity. E of xy means xy into f of xy dx dy. So we have to integrate with respect to both with respect to x as well as y. X limit 0 to 1, y limit 0 to 1. 2 by 3 is the constant term, you can take it outside. So here, when you are multiplying this, what you will get? X square, y square. First we integrate with respect to y. So what will get? X square y we are integrating, that is x square y square by 2. The next term, that is the first time we are talking about. The next term is 2y cube by 3. When you are integrating the term, substitute the limit, upper limit and lower limit. What you are getting is 2 by 3 is constant. Just substitute the limit for y. What is y? Y upper limit is 1. So here the term inside is y square. So we are substituting the value for this term. That is, so y square is what? 1. 1 minus 0, 1. So again we are going to integrate. So the term is x square by 2. So when you are integrating this term x square by 2, you will get x cube by 3. Already it is 2. So x square by 2 into 3 plus 2x y cube by 3. When you are integrating this term, y cube becomes 1. Why? Because we are substituting the limit. So 2x integrating or 2x square by 2. Substituting the limit for x, we are getting the value e of xy equal to 1. So next we have to find the covariance of xy by the formula e of xy minus e of x into e of y. E of xy we have already calculated. E of y is nothing but the mean value of x and y we have calculated. That is covariance of xy equal to minus 1 by 62. Okay. So from the covariance formula, so we are finding covariance formula. Here R of xy is the correlation coefficient. The formula for this is covariance of xy by square root of variance x variance. So when you substitute the values of the covariance and the variance, we are getting minus square root of 2 by 299. Either you can write in fraction or you can write in decimal. So the correlation coefficient is minus 0.0818. Next, you have to find the regression lines. By definition, you know the regression line is nothing but y minus y bar equal to byx into x minus x bar. We are substituting the value from this equation. What is the value? We are finding the byx minus Rxy into sigma y by sigma x. When you substitute the value, we are getting the regression equations for both y on x and x on y. Next, partial correlation. Partial correlation is a method used to describe the relationship between two variables. Correlation is also makes the relation variable, but here partial means what? Taking away the effect of the another variable. That means here involves three variables. One variable is fixed. That is what we are making the assumption here, taking away or removing the effect of the third one. And we are considering the third variable as constant. There is no impact of the third factor. So we are having the symbol, the partial correlation coefficient of x and y, controlling for z. Controlling for z means z has no role for that. We are removing the effect of z is given by Rxy dot z. Rxy dot z. That means z, the effect of z is stable, or we are not considering the effect of z, is equal to Rxy minus Rxz product Ryz. Rxy, Ryz, or xz are nothing but the partial correlation of x and y. In other words, they will say this is called zero correlation. According to the definition, the partial correlation is given by Rxy dot z. Same way, we can define the partial correlation coefficient of y and z, the last line, controlling for x. So we are taking without removing the effect, not considering the effect of x is given by Ryz dot x equal to Ryz minus Rxy Rzx by square root of 1 minus R square xy 1 minus Rxz square. So first you should know here whether it is Rxy, look at the first one, whether it is Rxy or Ryx. Both are one and the same. You can have write it anyway. Why? Because it is symmetric. Partial correlation coefficient is symmetric. So either you can write Rxy or Ryx. Both have the same impact. So we'll see the next one problem. Next line. Find the partial correlation coefficient for the following data. We are having three data, x, y, z, and we are asked to find partial correlation. That means by keeping one variable as constant or removing the effect of one, we are going to find the values of the remaining two variables. So the first one is Rxy dot z. Second one Ryz dot x. The third one Rzx dot y. That means in each and every case we are going to fix one variable or we are going to remove one variable, effect of one variable, and considering the correlation for the remaining two variables. So this is the formula for Rxy dot z, Ryz dot x. You can easily remember the formula. This Rxy dot z is nothing but Rxy, Rxz, Ryz here. You can easily able to remember this formula for this problem. Now we have to compute this correlation coefficient, that is Rxy for all. You know the formula how to find correlation coefficient by using the direct formula. We need this value for the table x, y, z. We are finding x, y, y, z, z, x square, y square, z square, and we are taking all the values, taking the summation. The last row represents the summation of the variable. That is sigma x is 32, sigma y is 40, the last row, and sigma z is 1 by 64, sigma xy is 125, sigma yz is 528, sigma x square is 112, sigma y square is 184, sigma z square is 2320. Okay, after finding all these values, we have to find the correlation coefficient for each and every variable xy, then yz, then zx. We have to find using the formula for the correlation coefficient. This is the formula to find the correlation coefficient. So we can use this direct formula. To find the value of correlation coefficient on xy. Then same way we can use correlation coefficient yz for the second one. Direct calculation n into sigma xy. Substitute the value. We are getting the equation a b, that is correlation coefficient. But in problem we are asked to find partial correlation coefficient. Sometimes they may give rxy, partial correlation, or to find partial correlation, sometimes they may give the correlation coefficient. From this problem, you can able to find partial correlation, that is the partial correlation coefficient of x and y. By the definition, it is given by this r of xy into xy minus yz. The value is 0.427. The partial correlation coefficient of yz for the controlling variable x, that is the last line, is given by definition ryz is ryz minus rxy ryx by 1 minus root of ryx. Okay, by definition we can able to find the partial correlation. One more thing we have to find. First one, we have fixed x here. You remove the effect of z. Here you remove the effect of x. The next one, you have to remove the effect of y. That is the next slide. You remove the effect of z, y. So on simplification, we are getting the value minus 0.384. So then we go for the multiple correlation. Multiple correlation is a study of combined influence of two or more variables on a single variable. Here we have considered x1, x2, x3 are three variables, are the observations. Then in the multiple correlation coefficient, x1 on x2 and x3 is given by r1 dot, the last line, r1 dot 23, the effect of x1 x2 on variable x1. So formula is r12 here, r12, r13 here, r12, r12, r13. Then all the correlation 1 2 1 3 2 3, all the correlation. Okay, so this time that is 2 3 come over here, r2 3 square. Similarly, we can define for r2.13, 3.21, all the variables we can define this multiple correlation. The next problem we'll see how to find the multiple correlation for a given set of data. We are asked to find from the following data, obtain the multiple correlation r1.2, that is the effect of x2, x3 on 1. Here r12.3 is the effect of x1, x3 on 2. So here the data they are given x1, x2, x3. So you know the formula to find the multiple correlation r1.23. r1.23 I have taken it as square. r1.23 is r12, then r13, then r minus 2 times r12, 1 3, 2 3. This one r23, this denominator is this one r23. Okay, you can easily remember the formula, but here we are asked to find what? r1.23. So here the formula is r square. So after finding this formula, I have to take the square root to find r1.2. The same way for the last line formula R square 2.13 for that also. Next data. Now you have to find a partial correlation for each and every data. You know this R12 means R x1 x2. R13 means R x1 x2. Okay. So we are finding all the values is total sigma x1, sigma x2, sigma x3, sigma x1 square, sigma x2 square, this value, sigma x3 square, sigma x1 x2, sigma x1 x3, sigma x2 x3. Okay. So we are finding all these values, summation total, and we are going to calculate this correlation R12, R13, and R23 using the correlation formula, or you can use the direct formula. Why? Because data is here. There is no need to find the variance, covariance, and so on. You can directly find the value directly. Direct formula, the correlation coefficient formula, and we are substituting the value x1 x sigma x1 x2 from the what is sigma x1 x2, sigma x1 x2 here 32,490. So from this we are writing the value of okay. So this is the total value, the summation for all the time sigma x3 square, sigma x1 x2, sigma x1 x3, and sigma x2 x3. Using the formula, we are finding sigma x1 x2 from the table. What is sigma x1 x2 for 32,495? Here we are substituting 32,495 sigma x1 from this side. What is sigma x1? 617. We are finding that as 617. From all the data, using the direct formula to find the value here, sigma R12, R12 for correlation. Then we have to find R13, R13, R23. R12 we have calculated. Similarly, we can calculate R13 using this formula for the data sigma n sigma x1 x3 minus sigma x1 into sigma x3 by square root of n sigma x1 square minus x1 whole square product n into sigma x3 square minus sigma x3 whole square. Substituting the value, n is what 10 data. Sigma x1 x3 is 6137 and sigma x1 equal to 617. Sigma x3 is 98. So we are all writing the data from the previous sigma x2 x3. From this data, these are the summation using all the data. Okay. So R13 you have calculated. Similarly, you have to calculate the other value R23. R23 n into sigma x2 x3 minus sigma x2 into sigma x3. By the fraction, we are finding the value sigma x2 x3 from the previous data. X2 x3 this data 5178. So writing the data from here for this 5178 sigma x2 sigma x3. N is 10. We are substituting all the values and simplifying, we are getting R23. So far we have find out R1, R12, R13 and R23. We have completed how to find the correlation between two variables. Next, you have to find the partial correlation. Partial correlation is R1.23. Formula R1.23 is nothing but R12 here, R13 here, R13. Then R combination minus 2 times R12, R13, R23 by 1 minus this 2, 3. Effect of x2 and x3. R23 square. Here we are asked to calculate R1.23. We are calculating the square of this. Okay, substituting all the values. R12, R13, R12. Here all the values. We are getting R square 1.23 equal to 0.63. Okay, so then find R13 is nothing but the square root of this value, that is 0.69. Similarly, we can calculate the multiple correlation of R2.13. Here 2 means the variable x2, x1, x3. These are all corresponding variables. For the, or you can say some quantities, relation to quantities, that is R21, R13, we have substituted the values, and R1.23 this value. So we are taking the square root of this, we are getting the value. Okay, remember that R21. Here I written R12. Don't forget R12 or R21. Both are one and the same. Okay, so because correlation coefficient is independent of change of origin, so we are writing here R12 or R21. Both are same. So after finding this R square R2.13, we are finding R2.13. That is by taking the square root. After the simplification, we are taking the square root. We are finding a value R2.13. So the next problem is also the same one, but here we are using another result. How to simplify? Here see this data 60, 68. The data are larger. To simplify the calculation, we can make this change of origin property. So here we are using the correlation, multiple correlation. We are using the correlation, multiple correlation. We are using the formula correlation. This is multiple correlation. This is a correlation. Okay. We know that by property the correlation R12 is same as R21 and symmetric as well as change of origin. We can simplify the calculation for the purpose to make it simple. Okay. We can also use a shortcut method to find the correlation. Just minimize the calculation. We are making the subtraction. Any value, the x1 minus 60 is of your choice. See the data 60, 68, 50. I have chosen 60 because 60 is here and 60 is here. If I taken the value which is repeated more than 2 times, the calculation will be simple. Okay, so that is what I have taken here. X1 minus 60 here. X1 minus 60. D1 equal to x1. Same way D2 equal to x2 minus 50. D3 equal to x3 minus 70. In order to make it simple, the choice is ours. You can take any value of your choice. Here I have taken x. In D3 I have taken x3 minus 70. The reason why, because see here 70 is repeated 2 times. So to make it simple, I have taken D3 x3 minus 70. The rest is same. You have calculated x1 square, x2 square, x3 square. Same way here you are calculating D1 square, D2 square, D3 square. All the total, the summation. We are not calculating because we are using the calculation D1, D2. So we are taking the summation. The summation D1, summation D2, summation D2. The last row, summation D1 square, summation D2 square, summation D3 square, We have taken all the values in summation over here, and we are using, now we are going to find the correlation R12 by changing the variable. It is x1, x2 becomes d1, d2. The reason is because correlation is independent of change of origin. So we have used this one x d1, d2. Here this summation d1, d2. Earlier it is summation x1, summation y8. So it becomes this variable. On simplifying summation d1, d2. d1, d2 is what? 325. From this table we have done here 325. Here summation d1 from the previous table. What is summation d1? It is 4. So I have done here summation d2 from the previous table. Previous table. Summation d2 is 50. d2 is 50. Okay. So we are finding the value. Substituting the value one after the other. N is 10 sigma d1 square from the previous table. What is d1 square? 554, 54. 454. Substituting all the values and simplifying, we are getting R1. The same procedure to find the partial correlation coefficient of 1, 3. After finding this correlation for all the variables R12, R13 and R23, we are going to calculate the multiple correlation. So this is the last one, R23. The formula we have calculated. And then we have calculated the value sigma d1, d2, d2, d3, sigma d1, sigma d2. All these values we have already calculated from the table value. And simplification, we are getting this value 0. Now we have to calculate the multiple correlation. As per the definition, the multiple correlation R1 dot 2, 3. Don't forget that 1, 2, 3 means all the variables, all the quantities. What is the effect of x1 on x2 and x3? R1 dot 2, 3. We have substituted the value R1 dot 2, 3 is nothing but R12, R13. These are our correlation we have calculated already. 1 minus R2 square. Okay. So on simplification, substituting the value and simplification, look at the last line. R1 square dot 23 is nothing but 0.480. The last line 4801 we have calculated. It is the square value. I have to find R1.23, taking square root. Last line, taking square root of 0.4801, we are getting the value 0.69. The last one, 0.69. So we will pass on to the next one. So we have calculated R1.23. Then we have to calculate R, the effect R2.13, R3.1. Okay. The same. You can calculate R2.13 by definition. R12 is nothing but this one. R21 is nothing but R21. R21 is nothing but same as R12. R23, R23. Then all this value R12, R13, R2. This one denominator 1 minus R this x1, x3 this value x1, x2. Substituting all the values R1 square, R12 square, this is R23 square, 2 times R12, R13, R23. Okay, so we are finding this R12 dot. Okay, so we have calculated the multiple correlation. In the next problem, we are going to find the multiple regression. How to find multiple regression? You know how to find regression for 2 variables. This is regression in case of 3 variables. The following table gives the weight, height, and age. So for this problem, they've given this data, and we are asked to find the regression line Z on X and Y. Z on X and Y. Earlier we have find Y on X and X on Y in case of two variables. Now we have to find the regression equation, that is most probably least square. That is Z equal to A plus Bx plus C. This is the, and the second part, you are asked to determine the estimated value. That means here Z is here. What will be the estimated value after finding the relation? What is A, B, C? We have some equation with relation between Z, X, Y. Estimated value means substituting the value X equal to 8, Y equal to 57. What is the value of Z? That is what estimated value. The last one, C part, estimate the weight of a boy who is 9 years. 9 years means they are given 8. Weight, we are asked to find weight. Weight means what? Z. Okay, so what they asked, what is the value of Z? Weight. Weight means here Z. What is the value of Z? Height and age is given. So using this, we have to find the value from this equation 1. Okay. So first, how to fit or how to form this regression line for the given data? Z equal to A plus Bx plus C. You can write the normal equation of 1 is given by, this is the normal equation, sigma Z, taking summation Na plus Bx plus C, taking the summation, the first equation of normal equation becomes sigma Z, the last line, sigma Z equal to Na plus B sigma X plus C sigma Y. The next line is nothing but just multiply this equation by X. Xz, Ax, Bx square. Okay, same. Multiplying by X. The next one, same equation multiply by Y. Yz, Ay, Bxy. You can easily remember the formula. We are multiplying first, taking summation, then with X, then with Y. So these are the normal equations. Okay, for this normal equation, to find the normal equation, you have to find summation Z. So what is the total? Z, sigma X, sigma X, sigma Y, sigma XY, sigma XY, sigma YZ, sigma XZ, sigma X square. Then you have to find sigma Y square. You have to find all the values from the table so that you can able to find the equation, normal equation. Normal equation. So these are the data. We have calculated all the values: sigma Z, sigma X, sigma Y, sigma Z square, sigma X square. All the values we have calculated, total values, and substituting the previous equation, that is the normal equation, sigma X. After calculating all the values, we have calculated sigma Z. N is what? The number of data. 12. 12 data. Okay, N is 12. We don't know what is A. That is what you have to find. Sigma X, sigma Z, sigma X, sigma Y. Okay. 12A, 63B plus C equal to this value. Okay. So we have calculated the, or we have, from the table, we have found the normal equation. That is the normal equation. These three are the normal equation. Solving this normal equation, we are getting the value of A, B, C. There are a lot of methods to get the value of A, B, C. Either you can use Cramer's rule, or from the first two, you can eliminate A. Then the second two, you can eliminate A. This equation eliminate A. This equation eliminate A. Then you will get the equation in terms of B and C. Then you can eliminate B and find C. So this is the regression equation z on x and y. This is the equation z on x and y. This is the value of a, value of a, value of b, value of b, and value of c. Second part, we are asked to find estimated value. We are writing z estimated, est, estimated value. Okay. So from the table z estimated, you know the relation of z equal to this value, equation from 3. See the table, what they given here. This is the value x, y. We put x value here. X is 57, y is 8, and we have calculated now the value of a, b, and c. You can find the estimated value of z at 64. 64 value is corresponding. See here 64. That is corresponding to the estimated value. We are searching the value. This is the given value. This is the estimated value. This is the given value. This is the estimated value. The last part of the problem, C part, what they are given, estimate the weight of your body. So we are asked to find what is Z when X and Y is given. So here they are given Y is 9 years. 9 years means age is 9. That is Y equal to 9, X equal to 50. Y equal to 9. 9 years old. 9 years means age. Age is 9. Height is 54. That's what given. What is the value of Z? After finding this equation, you can find substitute x equal to 54 and y equal to 9 in this equation. We are getting this value for this problem. Okay. So one more problem, just recall that what you studied yesterday. Calculate the correlation coefficient between two variables x and y. We are just calculating, we are recalling that what you studied yesterday, that is last class x, y. N is 25. They are given this data for the given problem. These are the data available. But in the problem later time, when you are checking this calculation, there is some error. We made some error. The observation 6, 14 and 8, 12 has been replaced, misprinted by this value. That means we have found that this value has been mistakenly typed. Okay, so we have to find after making the correction. We don't have what is xi and yi for the complete data. So how to carry out the error and how to make the correct calculation for this problem? You know the definition. Correlation coefficient is given by this direct data. Okay, sigma xi wave. So I have to find what is the correction sigma x, what is the corrected sigma y, what is the corrected sigma xy, what is sigma xi square, what is the corrected sigma y square. So we have calculated all the values. What are the corrected values? Corrected x. X means addition. Summation of x. We are given summation of x is 125. But what we did is here, we have made the correction here 6, 14. Fine. X is 6. X coordinate. X coordinate is 6. So what is y coordinate? That is 14. 6, 14. So we have to remove the incorrect total. Incorrect total. Incorrect total is this one. This is incorrect total 125. Wrong value. First subtract the wrong value. This is x value for the first pair. Second value x pair plus corrected value. Correct value is what? 18 plus 6. So the corrected value is nothing but 125. The next one, corrected y. The same way here, incorrect total. What is incorrect total? 100 minus this value, x value. Y value is 14 here. Y value is 14. This is the wrong value. So we are just removing the wrong value, 14 and 6. And we are just replacing by the new value. What is the new value of x, y, 12 and 8. We are adding the value, the new value for that is nothing but 100. The same way, we have to calculate the corrected word x square. X square is they are given. Incorrect total is what? 650. So here it is 650, and we are making the corrected value square. The error value plus the corrected value, we are adding a value, so we are getting 650. Sigma y square is nothing but 100 minus 14 square plus 6 square. Same way, sigma for the variable sigma y square. The incorrect is what? 100. Sigma y, the incorrect is 100, and here the 14 square minus 6 square. Okay, so we are calculating this value, that is subtracting, adding and subtracting, and getting that is 436. The corrected sigma xy they are given, that is nothing but 508. This 508, correct value is 508. We are using here the same way. We are just removing the mistaken values and we are adding the correct values. These are incorrect value. This is the wrong value. These are the correct values for this problem. Okay. So the equation 2 gives the corrected sigma xy, sigma x, sigma y. Okay. When you are substituting this corrected values here in equation 1, that is substituting 2 in 1, the corrected values here for all the values, we have to calculate the correlation coefficient for this case. We are substituting 2 in 1 for all the corrected sigma x, sigma y, we are getting the value for this corrected sigma x, sigma y. Okay. So we have seen today the problem how to calculate the correlation coefficient. Once again, we have recalled here, and we have discussed how to find regression line in case of continuous or bivariate distribution is given. It is f of xy is given. How to find regression lines, and then we have find out how to calculate the partial correlation using correlation. Then we have discussed the next part, multiple correlation, how to calculate multiple correlation using correlation coefficient. And the last part, you have seen the multiple regression. We have studied like y on x and x on y. Now we are studying z on x and y. Okay. Thank you. These are the topics we have studied.